continue with the class. We will start from where we have stopped in the previous week. We have done up to question number 10. So let's start from it. Question number 3 we have. Here is question number 7. So according to the question, f is a function, f of x is given as minimum of x plus 1 and mod of x plus 1. Then which of the following is true? There's something asking about differentiability. So minimum means we will take f of x as x plus 1. When you draw the graph of f of x equal to x plus 1, when x is 0, y is 1. So 0, 1. When y is 0, x is minus 1. So this is a linear equation. It's a straight line. Y equal to x. So you can see f of x is differentiable everywhere. You can go for option C. Next, I'll put question number 8 on the screen. P of x is given as x minus 1 whole power n by log of cos power m x minus 1, m and n are integers. X is in between 0 and 2, m is not equal to 0, n is greater than 1, and p be the left hand derivative of mod of x minus 1 at x equal to 1. If limit of p of x as x approaches 1 plus is p, then you have to find the values of m and n. So as per the question, p is left hand derivative of mod of x minus 1. Left hand means what? Derivative of minus of x minus 1. That means it is minus. Now, it's given that limit of p of x as x approaches 1 plus 2p. That means it is minus. And so what do you have? Limit of c x minus 1 power n by log of cos power m x minus 1 as x approaches 1 plus is minus. We will put x minus 1 as h. Let x minus 1 be equal to h. So limit h power n by log of cos power m h as it approaches 0 from the right side. First, applying the properties, this will be equal to minus. We will apply the property of logarithm. The power m will come out in the denominator. Log of cos h will be equal to 1. Next is we have to use L'Hopital's rule to find the limit. N h power n minus 1 by m, log derivative is 1 by x, 1 by cos h. Cos h derivative is minus sin h. This is equal to 1. This we will write as limit n by m we can take outside, h approaches 0. H power n by h power 1, n minus 1 we are writing. Cos h we will take up. Minus sin h, minus also we can take here. Sin h. So this is what it will become. This is equal to minus. This minus and this minus which we have here will get. Now n by m, limit h approaches 0, h power n cos h by h sin h. You have to divide by h and multiply by h. Equal to 1. So that this will become 1. N by m, limit h power n cos h by h square. Equal to 1. This will be n by m, limit of h power n minus 2 cos h as h approaches 0 is 1. If you put h as 0 for cos h, it will be 1. N by m, limit of h power n minus 2 as h approaches 0 is 1. If you see, m and n are integers. M is not 0. N is greater than 0. Then what you have? n by m limit of h power n by h power 2 as h approaches 0 equal to n by m limit of apply L'Hopital's rule nh power n minus 1 to h equal to. Apply L'Hopital's rule again. N into n minus 1 h power n minus 2 by 2 equal to. So n minus 2 must be 0 for position. N must be equal to 2. To make this power as 1. That you can do here itself. You need not do all this also. I have applied L'Hopital's rule. Without applying L'Hopital's rule also, if you want the answer for this limit as 1, the power must be 0. That means n minus 2 must be 0 or n must be equal to 2. Okay, this became 1. Now n is 2 by m equal to 1. That means m also should be equal to 2. M is 2, n is 2. Option 2 is the correct. Next, we will go to question number 9. Let f be the function mod of f of x is less than or equal to x squared for all x belonging to real numbers. At x equal to 0, we have to discuss about continuity and differentiability of the function. So we will take at 0 f prime of 2. F dash of 2. It will be limit of f of x minus f of 0 by h minus 0 as x approaches. F of 0 will be 0. So f of x minus 0 by x, or limit of f of h by h as it approaches 0. Now, mod of f of h by h will be less than or equal to mod of h. Because from this you can say mod of f of h is less than or equal to h squared. Using the information given in the question. That is what we have. That means f of h by h lies between minus h and. So, using squeeze theorem, limit of f of h by h as h approaches 0 will be. Using squeeze theorem or sandwich theorem. So, we got f dash of 0 is 0. That means the function is differentiable. Differentiable implies 30. So option B, continuous as well as. Next question, question number 10. F of x is cot inverse of x power x minus x power minus x by 3. Then f dash of 1 is. We can make some changes here in the function. Cot inverse x minus 1 by x, x power x minus 1 by x power x by 2. Or cot inverse x power x plus x. That is 2x minus 1 by 2x power 3. Or it is tan inverse 2x power x by x power 2x minus. It is nothing but looking like a formula. Tan 2a is 2 tan a by 1 minus tan square a. Only thing is here tan square a minus 2. That means we are assuming a as x power. So this will be tan inverse of tan 2a. Removing, but minus. There should be minus. So you can't remove tan inverse because denominator is different. That's why we have taken. That means I can write this entire thing as minus 2 tan of 2x power a. Now we will find the derivative. Minus 2 is a constant. Tan x derivative is 1 by 1 plus x square into, when you find the derivative of this inner function, 2 is a constant. X power x derivative is x power x into 1 plus log x. Here 2 will not be there. Here 2 will not be there. Now we will put x as 1. Minus 2 by 2 into 1. That is minus 1 is the option C. I'll put question number 11. Question number 11 is G is the inverse of F and F dash x is 1 by 1 plus x cube. Then G dash x cube. So we know that there is a formula. G dash of x is 1 by formula F dash of G of x. This formula we now we know what is F dash. Use that 1 by 1 plus G of x whole cube. So it is 1 plus G of x whole cube. That is option. I'll put question number 12. F of x is the function given as sine pi by 3 into greatest integer function of x minus x squared, where x is in between 2 and 3. Then f dash of square root of pi by 3 is equal to. Okay. Because x is in between 2 and 3, greatest integer function of x will be 2. So the function becomes sine 2 pi by 3 minus x squared. Find the derivative. Sine derivative is cos 2 pi by 3 minus x squared. Derivative of the inner function is minus 2. This is the derivative of the function. So f dash of square root of 5 pi by 3 will be cos of 2 pi by 3 minus 5 pi by 3 into minus 2 square root of 5 pi by 3. That is cos minus 5 and minus 2 root 5 pi by 3. So here minus and minus will become plus 2 root 5 pi by 3. Option B. Okay, we will go to question number 30. Here is question number 30. If square root of 1 minus 2 x power 2n plus square root of 1 minus y power 2n is a into x power n minus y power n, then square root of 1 minus x power 2n by square root of 1 minus y power 2n dy by dx is equal to. So to make the question easy, we will put x power n as cos alpha, y power n as cos theta. So we have square root of 1 minus cos square alpha plus square root of 1 minus sin square alpha. Actually, this we have to write square root of 1 minus cos square theta equal to a into cos alpha minus sin theta. Square root of sin square alpha is sin alpha. Square root of sin square beta is sin beta equal to a into cos alpha minus sin. Now, a will be equal to sin of alpha plus sin of theta by cos of alpha minus cos of theta. Applying transformation 2 sin alpha plus beta by 2 cos alpha minus beta by 2 by minus 2 sin alpha plus beta by 2 sin alpha minus beta by 2. So we have tan of alpha minus beta by 2 as minus 1 by 3. Or alpha minus beta by 2 will be equal to tan inverse. Cos inverse x power n minus cos inverse y power n equal to 2 tan inverse A. Derivative of cos inverse is minus 1 by. We have minus 2. Minus 1 by square root of 1 minus x power 2n into x power n derivative is nx power n minus cos inverse derivative is minus 1 by square root of 1 minus y power 2n. Y power n derivative is n y power n minus 1 into dy by dx equal to 0. So dy by dx will be equal to nx power n minus 1 by square root of 1 minus x power 2n into square root of 1 minus y power 2n by n y power n minus. N and n will cancel. As per the question, we already have square root of 1 minus x power 2n and square root of 1 minus y power 2n. So in order to find this, what we have to do is, we have to get square root of 1 minus x power 2n by 1 minus y power 2n dy by dx equal to x power n minus 1 by y power n minus. That is all it is. Next is question number 14. It is similar to the previous question. Square root of 1 minus x power 6 plus square root of 1 minus y power 6 is a into x cube minus y. And dy by dx is f of x y square root of 1 minus y power 6 by 1 minus x power 6. Then which of the options you will select? So as we have taken the previous question, x cube you take it as cos b, y cube you take it as cos. So we have square root of 1 minus cos square b plus square root of 1 minus cos square cube equal to a into cos b minus cos. That will be sin p plus sin q by cos p minus cos q is p. So a is 2 sin p plus q by 2 cos b minus q by 2 by 2 cos p plus q by 2. 2 sin p plus q by 2 sin p minus q by 2 is minus. So 2 and 2 will sin p plus q by 2 also will cancel. And so as we had in the previous question, same way we can write tan of p minus q by 2 equal to minus 1 by 2. P minus q by 2 is tan inverse of minus 1 by 2. P will be cos inverse x cube. Q will be cos inverse y cube equal to 2 tan inverse minus 1. Derivative of cos inverse is minus 1 by square root of 1 minus x power 6 into x cube derivative is 3x squared. Minus derivative of cos inverse is minus 1 by square root of 1 minus y cube whole square, and y cube derivative is 3y square dy by dx, which is equal to. So dy by dx will be 3x square by square root of 1 minus x power 6 into square root of 1 minus y power 6 by 3y square. 3 and 3 will cancel. And then you can write square root of 1 minus x power 6 by 1 minus y power 6 dy by dx will be equal to x squared by 6. That is option. Next is we will go to question number 50. F of x is 1 plus x whole power s, and the value of f of 0 plus f prime of 0 plus f double prime of 0 by 2 factorial, f nth derivative of 0 by n factorial. So f of x is 1 plus x power n. F dash of x is n into 1 plus x power n minus 1. F double dash of x is n into n minus 1 into 1 plus x power n minus 2. F triple dash of x is n into n minus 1 into n minus 2 into 1 plus x whole power n minus 3. Like that, f nth derivative will be n into n minus 1 into n minus 2. So on up to 1 into 1 plus x power n minus x, that is 3. So it will be n factorial. So what is asked in the question? You put 0 everywhere. F of 0 is 1. F prime of 0 is n. F double prime of 0 is n into n minus 1 by 2 factorial. F's nth derivative at 0, n factorial by n factorial. This is what we do. So this is C0, this is C1, this is C2. So on up to Cn is 2 power. So option B is. Let's go to question number 60. If alpha and beta are the roots of the equation e power x cos x equal to 1, then the equation e power x sin x minus 1 equal to 0 is 4. So we know that e power alpha cos alpha is 1. E power beta cos beta is. Now we will take f of x as e power x cos x minus. Then what we have is, we'll take f of 0, which will be 1 minus 1, that is. We'll take f of 1. So we must get the same. Because we know that this function is continuous and differentiable. Continuous and differentiable. We know it. So if you take f of alpha minus f of beta, 1 minus 1 0. That means f of alpha is equal to f of beta. That means Rolle's theorem is applicable. That means the function has at least one root in the interval alpha beta. Option C is the correct. Next, we will take question number 17. F of x is x into mod of sin x. You have to see about its differentiability. So it's a piecewise function. F of x is positive x sin x, negative x sin. When it is positive, when it is in first and second quadrant x, that means it should be between 2 and pi and 2n plus 1 pi. When it is negative, when it is in the third and fourth quadrant, that means it should be in between 2n plus 1 pi and 2n plus 2 pi. Because they are talking about x equal to n pi, f dash of n pi we will find. It's limit of f of x minus f of n pi by x minus n pi as x approaches n. That means it is the limit as x approaches n pi. F of x is x mod of sin x. N pi will be of course 0. F of n pi will be 0 over x minus n. So it is different x minus n pi bottom should not be 0. So f of x is differentiable. Only thing is x should not be equal to n. Option C is the correct. We'll go to question number 18. F is a function given as d5 function x square mod of cos pi by x for x not equal to 0 and 0 for x equal to 0. The set of points for which this particular function is not differentiable that we have to. First, we will see what is at 0, f of 0 is 0. Then we will see limit of the function as x approaches 0, that is x squared, mod of cos of pi of x as x approaches. So this is 0. Both are equal. That means the function is continuous at 0, especially at x equal to 0. Now we will check the differentiability. F dash of 0 is limit of f of x minus f of 0 by x as what is f of x? X squared cos of pi by x. We will see the left derivative. Left derivative means f of minus h. Here also minus h. So this will be limit as h approaches 0 minus h cos pi by x. When you put h as 0, this left limit you are getting left derivative. Now we will find right derivative. Similarly, you will get this also as that means f is differentiable and continuous as x equal to. But If you take mod of cos of phi of x, f will not be differentiable at x equal to. That means f is continuous but not differentiable. So you can take off. Why option C? Because f of x is not differentiable if mod of cos pi by x will be 0. That means cos pi by x is 0. That means pi by x being odd multiple of pi by 2. Or x is 2 by 2n plus. So don't include 2 by 2n plus. That's why we are selecting option. Next is we will take question number 19. This question is too big enough. So 19th we'll do it in the next one. See you till then.